All right, Dean, KK4DIS. It is SolderSmoke 257, kind of a special edition. We're going to talk mostly about the SolderSmoke Challenge Direct Conversion Receiver project. Our
Yeah,
our
I'm looking forward to it.
our buddy Pete's not here. He's got some pressing family responsibilities, and he has announced on his blog that he's not going to be a regular participant, but he is going to be coming back from time to time, sharing the tribal knowledge that he has been dispensing all these many years. Pete, we wish you the best of luck with everything, and we hope you be back here soon. What we're doing today
Hey,
is
Bill, before we jump into the direct conversion receiver, up here at Solder Smoke Great Falls, it's 26 degrees. I'm not going
it's
outside
but wait
today.
a second.
How is
It's
it?
it's 26 degrees here also.
Wrong
The
system,
letter
Bill.
afterwards is 26 degrees C here. I'm looking at my smartwatch. It's 79 degrees Fahrenheit. Yeah, I
Well,
guess
I
yeah,
hope you're enjoying it. That's all I can say.
yeah, you can't see it right now, but I have sneakers and short pants on. I put on a shirt here. This is the only time I put on a shirt with a collar since I've been down here, I think. Um, Last night, but by the way, you launched us into travelogue. Last night, we are sitting out on the back porch, just sitting there watching the sunset. And Elisa leans over to me and she's got her phone in her hand. It's got Instagram on it. And she says, "Look at this." And it shows a map of the Dominican Republic with a Falcon 9 rocket coming down from Cape Canaveral right over the central part of the country. And I look and I say, well, what time is it going to be? And I look and it looks like it's about 20 or 30 minutes away. So I call up on YouTube, I call up a live feed from Cape Canaveral, and sure enough, they're getting ready to launch a Falcon 9. It's got like 23 Starlink satellites on it. So I said, I started calculating, okay, where's northwest? Because that's the direction. It looks like it's flying over the middle portion of the Dominican Republic. We've got to look west. So I tell everybody there, I said, look, we got to look over here. And so I'm watching on the phone, I'm watching the thing launch from Cape Canaveral. It goes up, and sure enough, Dean, like a few minutes later, one of the caregivers for my mother-in-law just yells, "There it is! There it is!" And I look over, and on the northeast horizon, sure enough, you see this thing shooting up. And it's clearly the rocket. It's not a meteor. It's not moving fast enough. It's not an airplane because it's got a trail. It looks sort of like a comet, but a comet would be sort of stationary in the sky. This thing is moving. It's clearly the Falcon 9. So we watched the Falcon 9 track across the center of the Dominican Republic. We could actually see it when it reached main engine cutoff. When all of a sudden you saw the trail disappear, and for a brief second you saw the vehicle continue into the darkness. But I've got a video up on the blog. Check it out. The same video is on the YouTube channel. But
That's fantastic.
I've never been present for a launch, but I feel like I have now because I mean we're a good 800 miles to the southeast, I think, and but it was really cool. We were going around today. Everybody in the Dominican Republic's talking about it. It's all on Instagram. There's all kinds of pictures. It was really cool. I mean, it was out there
Uh,
for several minutes. I mean, for 5 minutes or so.
I was fortunate enough to see one from Vandenberg at Thanksgiving this past year. I
That's
took
right.
some pictures of it, and it was yeah, it's pretty astounding.
Apparently, they like to shoot from Cape Canaveral during the summer months because the drone ship is parked somewhere near the Bahamas, and the waters are calmer during the winter months, and so the waters are calmer during the winter months in that area. I don't know if that's true because we've had some pretty rough seas here lately, but wow, this thing was really cool. So anyway, that's a little bit of the travelogue. So listen, I'm gonna we'll talk about let's talk about the direct conversion receiver project because all of this started when I kind of flippantly issued a challenge to the ham radio workbench guys, then followed up with a challenge to the broad solder smoke community and said, build this receiver. And then you jumped in and said, I'm going to show them how to build this receiver, which was fantastic. And that was in January. The whole thing started in January. We're in February. We've already had tremendous success. I think it's tremendous success. It's almost like a vindication because this all started with the local high school. Didn't have a whole lot of success there. Well, we didn't have any success there, but Now we've had success, and we've got a pretty high standard for what constitutes success. Somebody has to actually get the receiver working, and
So, some say our standard is too high, Bill.
well, you were the one who introduced we need proof of life.
Proof of life. That's what I said.
We need
Yep.
a proof of life video.
If
So
you're gonna if
guys,
you're gonna hit if you're gonna hit our Hall of Fame, we need to know.
we don't, yeah, and we don't want to just hear you say that you got it working. We want to see the video of it actually inhaling. And so far, we have received 22 such videos. I mean, it's really kind of heartening. You know, the guys have come back saying, "God, I've been a ham." One guy said, "I've been a ham for 48 years and I never built anything, but now I've built a receiver." So many guys say, you know, I did my undergraduate as an electrical engineer, but I never did anything like this. This is really great. I think it's been a good project. I think your tutoring has been excellent because you've shown them how to do this. I think the design choices that we made early on were on target, and because we wanted to give people the best, not only the experience of building a useful device, but of home brewing, of actually making it with their hands, making something. So I think it's been
Yeah,
great.
so I tried to because I have been at this far less time than you, Bill. You'd been doing this since you were 13. I started when I was, in my 50s. So it I still have the memory, very real memory of getting that Rigel oscilloscope and not knowing how to turn the dials and not knowing, how to identify the leads of a transistor. And I was just thinking, look, I think there are others like me out there that want to learn this stuff, but seem a little bit intimidated by getting started. And so if we do this in a very straightforward way, one board at a time, I promised myself that I would answer every question, regardless of how irritated the questions made me. And I've been trying to do that. And sometimes they get a little, you know, it's like,
You have more success than I do, Dean. You have more
but
success
I
than I
try
do.
and answer every question. And we've gotten through the four boards and so here it is. This is the what I would call the version one or serial number one of the actual SolderSmoke challenge direct conversion. This is the one I built while we were doing the build over the last month. It looks very much like the one I built for the high school students. We've changed the circuits a little bit, but this is the 100%. Yeah.
Yeah, this is the one. This is one of the ones that we did for the high school kids. And I mean, through pure luck, I threw it in the suitcase as we were heading down here. I didn't realize at the time that it would provide a useful tool because very often guys would ask questions about, well, what does the waveform look like at the junction of the PTO and the mixer? Well, I could just fire it up, hook it up to the Regal oscilloscope you see over there, and provide an answer. I'd say, well, it looks like this on my receiver, right? Which
Right.
actually provided a kind of a good basis for comparison as we went through. But anyway, yeah, I think it's been a fantastic achievement for all the 22 guys who so far have built it. You know, I think we have at least 35 a total 35 other receivers are in the works.
That
So
we know of,
that we
right?
know of. There are others out there that we don't know about, but we imagine that this project is going to continue. There are going to be people who, for life circumstances or for because they heard about it later, will come to it later. Your videos will remain there. It's the discussion is being carried out on a Discord server, which is a new thing for I think for both of us, but it's proven to be very useful. All of those discussions will be there. So even if we are pulled away by other responsibilities in life, which could happen, the project will be there, and anybody at any time can initiate it and join the club of actual home brewers. You know, one thing I'd say, you know, I put up on the Discord channel a couple times quotes from Farhan because Farhan VU2 ESE in Hyderabad, India, he in the course of presenting his many rigs, beginning with the BitX20, I guess even before that, but the BitX20 is the one that I remember most. He talks about how building a receiver is an important milestone for an engineer. And he says, I don't define engineer. He doesn't define engineer as whoever has the degree, but rather anyone who applies technical knowledge to a task at hand. And that's definitely what we're doing here. And he says, building a receiver is a basic way to establish basic technical competence over the device. If you've built the receiver, you can do that. So we've seen people just doing that in a lot with the four boards that you mentioned.
So let's step back a second and kind of review the bidding. So this is a simple receiver. We keep saying it's simple. It really is simple. It's four boards. We use a 3D printed form for a coil. That's going to be the coil part of our the inductor part of our oscillator, and then we've got a Colpitts oscillator, simple Colpitts oscillator. So that's the oscillator board. Then you've got a four diode ring mixer, real common, inexpensive diodes with a couple of transformers. Got a bandpass filter because you got to get yourself on 40 meters, and you have an audio amplifier. That is the receiver. In fact, we demonstrated that with just the PTO and the mixer, you can actually receive. It's a very, very simple design. And, Farhan's suggestion was just four boards, and he had done this with a group of girls in a similar receiver, not the same one, with a group of girls in Hyderabad, and we were inspired by that. And so we did it with the high school class. Now we didn't have as much success with the high school class as we would have liked to, mostly because of scheduling issues and interest from the administration. I think if the administration and teachers had been a little more excited, the students would have been a little more excited, and we'd have gotten through it. But nevertheless, we've been excited about it, and we're pretty happy with it. Now, a couple of things with homebrew that were learnings for me when I started doing this that we tried to emphasize is that you have to trust the schematics, but verify, because sometimes there are mistakes. And in fact, even though I've built this receiver 4 and 5 times, we did it for the high school kids, there were mistakes in the schematics that we posted. And so they've been updated 3 or 4 times as we go. And I'm guessing there are still mistakes in the schematics that people, because you don't see it after a while. So we update them as we learn. This happens in software, by the way, all the time. I'm a software developer by trade, and version 2, version 3, 2.1, 2.1a, because we fixed the thing that we broke in 2.1. This happens, and that's just part of the
Yeah, we talked about this, Dean. And when you think about editing, if you're going to edit a novel or a nonfiction book in the English language, it's relatively easy to find people who can read through the text and spot errors, spot, verb noun disagreement, things like that. That's easy to do. To find people who could look at a schematic and determine that you put the electrolytic capacitor in backwards, that is pretty rare. That's probably why we see so many errors in the schematics published in QST or in the ham radio books. It's almost impossible because you could look at it, you yourself can look at it. You're probably the only one who's going to look at it, and even you won't see it
Yeah, and
until
when I sketch them on a sketch pad, I don't pay too much attention to the exact symbol I'm using for the capacitor. And of course, when you pull them up in LT Spice, there's a different one for an electrolytic capacitor. There's a different one for a non-polarized capacitor. And a lot of times you just grab a capacitor and say, well, I need a cap here. I need this. And you don't pay as much attention to that as you should. And even after fixing those a couple of times, I still had a couple of them wrong. So it just
yeah,
goes with the territory.
sometimes this is, I think, one of the points of irritation because sometimes you would sense a lot of times for the people, well, sometimes from the people who are writing in, kind of an irritation with the fact that, well, you said that it was this value, and now you're saying that it's that value. And our answer is, yeah, we did say that, and now we're saying this because we think it's better this way. We've discovered an improvement. And we improved this circuit in the course of doing this particular project, and I'm grateful for that. So I think it's a better receiver now than it was when we started. It was good when we started. It's better now.
Well, this gets into uh, a topic that I want to address. When we started on Discord, the very first people that came on were what I would call electrical engineers who know better. And they wanted to give us better circuits and different circuits and critique our design because it wasn't optimal. And I finally said, stop, because it's actually harder more difficult to make a simple receiver with simple parts that works well than it is to use all the textbook best practice complex circuits. It's actually harder to do simple. And we chose to do simple. And our watchword was as simple as possible, but no simpler, right? Because we wanted a receiver you could use when you were done, and we achieved that. And largely that has tamped down. We're not getting as much of that anymore, but there is an insatiable desire for experts to want to weigh in on a project like this. And all I would say to them is first build our receiver and then tell me why you need to improve that circuit or this
Yeah,
circuit and what is it that you're trying to accomplish that we haven't accomplished.
that's a very important point. And I'm always reminded of the quote, and it's usually attributed to Voltaire. Don't let the perfect be the enemy of the good, or the good enough, as we would say. And we made choices, and we actually described the process. An engineer could look at what we did and say, well, it'd be better if you did this, it'd be better if you did that. Why don't you do it this way? Basically, it comes down, why don't you do it my way? But we, at every juncture, decided to do it this particular way because even though it might not be optimal, it was the simplest way to do it, and it would provide the best learning experience for the students. The students would see how a common emitter amplifier works, how you take three of them, one after the other, to boost the signal to the level you need, why the PTO puts out a signal the way it does, and how that affects the operation of the diode ring mixer. What does the bandpass filter do? So all those things there, yeah, you could nitpick, and I'm glad you told those folks to stop. Many of them, I think, actually would say after a while, yeah, you're right. I'm just letting my EE self take control. And we would say, fight it, my friends.
I actually put in the getting started post on Discord. I said, for those of you that cannot help yourself and know that there is a better and more optimized version of the circuit, we know and we don't care.
But getting back to the four boards, one of the things that Farhan pointed out a long time ago, that there are four basic circuits. There's a filter, there's a mixer, there's an oscillator, and there's an amplifier. And if you take those four circuits and put them together in different ways, you could build just about every electronic device that exists in radio. So this project is good because we did use exactly four boards. We have a BP filter, we have a diode ring mixer, we have an oscillator, and we have an audio frequency amplifier. So this is a way for somebody to demonstrate competence. One thing I would say is that, it flies in the face, what we did here flies in the face of advice that had been pumped out by the authorities in ham radio for decades. For decades, hams were told that, well, yeah, you could build a transmitter, but, for the receiver, you probably need to go with the commercial product. Not true. You could build a useful receiver, and this is an extremely useful receiver. It sounds great. A direct conversion receiver, as Pete has pointed out on the podcast, the direct conversion receiver really sounds fantastic. It's got an amazingly good sound quality to it. One thing I'd like to point out, I want to take a shout out to one of our first builders, and that's Scott, KQ4AOP. He did something unusual. Scott wrote in and told us that the very first amateur radio signals he had ever heard with his ears came through one of these receivers. He built the receiver. That is a great way to begin your ham radio story. And none of us, I can't say that. I don't think you can. I don't think
No.
anybody else on the Discord server can say it, but Scott can. So three cheers to Scott for that.
We may have some who are close to that level. There's a few that say I'm brand new to this. Some of them didn't know what an antenna was. So yeah,
Yeah,
it's good. So let's talk about the boards, Bill. Let's see.
that's
So
that's
we
a good way to
started
do it.
with we started with the oscillator for a couple of reasons. One is without an oscillator, you can't tune anything. It's not, but the more important reason, once you've built an oscillator, whether you know it or not, you've actually built a CW transmitter. You can actually transmit with just that oscillator. You've experienced what Bill has coined the joy of oscillation, which is a little weird, but
It's kind of weird. It is
it is
weird.
true.
Yeah, but Dean experienced it about 4 or 5 years ago when I sent him on a cold winter day a crystal for 3.579 megahertz.
Yes,
and we defrauded the post office I did anyway,
we did.
and then your wife
I
had
had
to
to
go to
pay
the
them.
post. I had to pay them for the shipping fee because a crystal constitutes a parcel. You see, anyway, it's a long story, but anyway, you're right. We were able to do that with the oscillator board.
So it's kind of a mishmash. Again, people will sometimes complain when you're doing homebrew that you're not really engineering. It's not really your circuit. You didn't really design that. Well, the answer is nobody designs from actual first principles, right? Everybody uses common circuits, but you do engineering. You put things together. So we started with the PTO that Farhan built for a receiver that he called the Daylight Again. It was an all analog. He stepped back from his digital S-Bidex kind of SDR route, said, I want to do an all analog device. And he came up with this idea of using this 3D printed form. And that's kind of what we picked up. We picked up the kind of basic oscillator circuit from there, but we didn't use his entire oscillator circuit. We said, we want it simpler. We want just a simple single buffer amplifier. And we basically started with that and adjusted it so that it worked on our 40 meter band. We needed to change out the emitter resistor to make it go. Yeah, we started with Farhan's, but we made it ours by the time
Yeah,
we were done.
and Farhan started with Colpitts. I mean, it's basically a Colpitts oscillator, and that was there. And then we liked it because of its simplicity, because it had the frequency determining capacitors in there, and they were the same capacitors as the feedback capacitors. This reduced the parts count, made it really, really simple. And we knew it worked because Farhan was using it in Hyderabad. Then we
And
needed a
but even that idea, right, which
yeah.
is combining the caps so that you're using the same caps for feedback and for the tank circuit, is not a new idea.
No, it's
It's
not. It's
something
right.
it's something that's been done for decades. You can find it in books.
Yeah, well, Dean
Uh,
makes an important point because often you'll hear guys who are speaking on a commercial rig, by the way, they'll say something like, and when you tell them that you're using a homebrew piece of equipment, they'll say, "Ah, yes, but did you design it yourself?" And we always laugh because you imagine somebody sitting there with a blank piece of paper and no knowledge of electronics, no knowledge of prior circuits, thinking, "Hmm, how can I make an oscillator?" You know,
yeah, well, there is that.
yeah.
So a couple of things about the oscillator circuit. So in the frequency determining components that Bill just mentioned, you've got some capacitors. And we learned pretty early on that the best caps to use if you want a rock stable VFO at 7 megahertz are silver mica caps. The NP0 little ceramics work and they're good, but they're second best to the mica caps. The generic, you don't know where this cap came from, they don't work well at all. The thing drifts all over the place. But if you use silver micas and you use care in winding your PTO and you ground it, the thing is rock solid. And this is, again, it goes against conventional wisdom that you can't build a stable analog oscillator that doesn't drift. This thing does not drift. You
It's
can
really
turn it
great.
on, and 15 minutes later, it's on the same frequency it was before. It just doesn't drift. And so you can do it. But we've had, some of our makers on Discord have had chopping channel challenges, and so getting things like the silver mica cap seemed to be a problem. But we just said, look, this is part of home brewing. You gotta acquire the parts.
That's
That's
it.
that's part of the deal.
One of the parts that I want to mention is one of the parts that caused, I think, the most consternation frankly, among the EEs in the group, and that is the brass screw.
Oh, well,
It
there is
it
that. Yeah.
it just seems so barbaric that you would change the frequency by moving in and out of a coil form, a
Oh, Bill, one of our
brass screw.
builders, one of our builders found that a toilet flange makes the perfect brass screw, and I love that. I
I love it
absolutely love
too.
it.
You see, the thing is, Farhan's design started with a brass screw, and he called it a PTO, a permeability tuned oscillator. But purists out there will point out that brass has the same permeability as free space. So as you move the screw into the coil, you're replacing free space with brass. So therefore, you're not really changing. Okay, it's a long discussion, but it doesn't really matter. We call it a PTO because it looks a lot like the Collins kind of style oscillator, which had kind of a screw moving in and out. There's a lot of
And
ways you can
it
modify it.
is changing the inductance as you move the
It
screw in and
changes
out.
the inductance. Not maybe it's a yeah. We could come up with a different name. If you change it to a steel screw, it does change the permeability too. So therefore, it's okay if it's a steel magnetic screw. But anyway, we overlooked it because what Dean said is the most important thing is that it changes the inductance. And we told people, look, start out with the brass screw, build it that way. One of the reasons that it was better for them to start out with the brass screw is that we knew that we would be advising a lot of people along the way. And it would really, really mess us up if we were given advice and all of a sudden the guy said, oh, but wait, I'm using a different part, or I'm not using that particular circuit, I'm using this particular circuit. That would produce some kind of offline weeping and gnashing of teeth. You would say,
Yes, it would.
it would. And you would say, well, listen, I'm giving advice based on what we said in the beginning, which was build the circuit that we wanted to build. Afterwards, you could, modify it to your heart's content. But anyway, uh, the metallurgy seemed to be important, and there was a lot of discussion about whether we should use brass or steel or some other alloy. We said start out with brass. We actually have a pretty good mod page on how to go to steel and how to change the frequency variation of the inductor and of the oscillator. It's there. Anybody wants to do it. I actually did it in this receiver here. You'll note that I have a kind of a steel screw here, and you can see I have an additional coil here. So
So
it
Bill,
can be done.
I want to tell you a secret, but you can't tell anybody else.
Tell me, tell me.
I found out that if you replace the 600 picofarad caps
Yeah,
with 500 picofarad caps
yeah.
and you scrunch down the windings on the PTO, it tunes beautifully linearly and you don't
Oh
have to do
man.
anything else.
See, that's
But don't
another
tell
mod.
anyone.
Don't tell anybody. Shh. Anyway, but these are the kind of mods that we're looking for that are fun and that will be good after the initial receiver is built, after the first one.
Well, that's really important. We've probably had to say that to 54 builders. Build it to spec first, then try mods, then try changes, because partly because we're doing this as an internet project and we're having to help everybody. And so when we first started, there were two versions of the schematic on Hackaday. Bill had a version, I had a version. We've had other people make them, and everybody was referring to different part numbers on different schematics. So I finally said, to quote Pete, "Basta!
Yeah,
These are the schematics we're using."
that's
And
right.
I posted, and I froze the schematic channel so that no one could modify it and no
And
one
but
could comment on it.
we would still have guys say come back a couple weeks later saying, "Well, I'm looking at the schematic and I see an error there." We'd say, "Wait a second, no, 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 you're not looking at the right one. Look at the one that Dean said. That's the one. That's the only official schematic." Yeah,
We have we yes, it's the what was the word the guy
canonical,
used? It's
canonical,
the canonical
the
schematic.
canonical
Yeah.
schematic. Yes.
All right, so that's the oscillator. Let's go on. So once you had that done, you had experienced the joy of oscillation. Oh, by the way, I said we're going to move on, but we also got into what I would call oscilloscopeology at this point, because some of our builders, and I'm glad they did this, went out and bought their oscilloscope. And then they tried to hook it up, and they found that, much to their chagrin, that they couldn't get the signals that I was showing in the video. And it turned out, just like when I got my first scope, it's a learning curve, and you actually have to learn how to do the settings. So along the way, I have posted some what I call bonus videos that are not just about the boards. I did one on soldering because guys were having trouble just getting the solder to the brass boards, and I did one on the oscilloscope. But you actually have to learn how to use your tools in order to do this kind of work.
Yeah, it's very important, and it was really heartening that so many guys got scopes because that does provide a good basis for future homebrewing. It means that they're not just thinking about this project, but they're thinking ahead. But it is also important to, as Dean said, to use the instrument properly. And
We did show that you can tune this thing without a scope. You just put a receiver next to it. We know you're going to be close to the 40-meter band if you just build to spec, and you can tune up and down, and you can find the signal, and it'll start whoop 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 when you find
Yeah.
it and you tune it in. And some of the guys did that, and that's good. I thought maybe I was going to have to do a side video on building an RF probe. I didn't have to, which is
Yeah.
good.
Yeah.
Although someone mentioned it along the way.
Yeah.
So kind of that's the oscillator board. Should we go on to the mixer?
Yeah, the mixer. One thing, Dean always teases me for being a mixerologist and having spent excessive amount of time studying the operations of mixers. I really like the diode ring mixer. I like the way it works. I think Alan Wolke, W2AEW, has an excellent way of describing how it works. But the main point that we made with the people who were building this receiver was that you should try to understand how the diode ring mixer does its thing. And the most important thing to understand is that what the PTO does with the mixer is that it turns on and off different pairs of diodes. And this results in a multiplication of 1 when it just passes the RF signal through, or a multiplication by -1 when it flips the signal and sends it through. And there are diagrams out there. One of the best is by the RSGB that shows how this multiplication by 1 and -1 will produce the sum and difference frequencies that we use as the basis of the direct conversion receiver. And it was really heartening when some of the guys actually took the time to study this, and you could see almost detect the light bulb going off. One of them would write in saying, I got it, I could see it. And what we would do is when we were testing the PTO and the diode ring, one of the best ways we found to test the functioning of both key circuits in this receiver is to just put the scope probe at the junction of the PTO and the diode ring mixer. And we could tell from looking at the waveform at that point whether the PTO was producing enough signal to control the diodes and whether the diodes were actually switching on and off. And
this was actually a new learning for me, because I had looked at that before and saw, wait a minute, the waveform is distorted when it's hooked up. Is there something wrong? And the answer is no, there's not something wrong. That is the impact of the diode switching on and off that turns the sine wave into what looks a little bit more like a square wave.
That's right. And the fact that you're seeing it as a square wave indicates that two things. It indicates that you've got enough PTO signal, which is very important, and that you've wired the mixer correctly, because that PTO signal is turning these diodes on and off. So when you see that,
I didn't post this in the video, but when I built the mixer for the video, I actually had the right hand two diodes in backwards. And you know what happens? It only rectifies half of the waveform.
that's right. That's right. That's it. Yeah.
So you're seeing half, but you're not seeing the bottom half.
You're not seeing the bottom half.
And I looked at that and I said, wait a minute. And again, this is another point I made, that it's easy to make a mistake when wiring in parts, particularly those that are that have a polarity to them. You have to take a lot of care in doing that, because it's easy to get them wrong.
We had several builders come in and say that they just could not get the circuit to work, and we would tell them check carefully, and they would come back a day later saying, I just found out that the transistors were wired in backwards, that I put the emitter where the collector should be, and vice versa. So yeah, I mean, we're all prone to those mistakes. It's a good lesson for the home brewer. Even when you think you've got it perfectly, very often it pays to get a good night's sleep, look at it again in the morning, and then you're going to discover, whoops, you forgot to put in. I have done circuits where I completely built the thing, and then I'm stumped. Why is it not working? Well, I didn't put in the transistor. Believe me, amplifiers don't work if you don't put in the transistor. It happens. Hey, one thing
I tend to go through the schematic, and I tick off each part after I solder it in. Even doing that, I've left parts out.
Hey, one thing I wanted to mention, people might say, why did you guys go with the diode ring? Why didn't you go with a simpler mixer? There's plenty of simpler mixers out there. There's one diode mixer, there's two diode mixers. And we tried the two diode mixer. You'd have two diodes and you'd have one trifilar transformer. This is a very common circuit. It's a singly balanced mixer, not a doubly balanced mixer. And we would have done that. We would have gone with that. But in Northern Virginia, where Dean has a house and I have a house, we have a lot of RFI. And when we used that circuit, we found that we were getting a lot of AM breakthrough on that circuit. So we decided to go with the diode ring. When we went with the diode ring, the AM breakthrough just really dropped off considerably. So that's one of the reasons that we went with what could be considered a somewhat more complicated circuit.
And we added the diplexer circuit at the output for the same reason. Try and knock down that AM breakthrough, make sure that the only signals that we're getting to that audio amplifier were the ones that you want. Because in a direct conversion receiver like ours, 100% of the gain is in that tiny little audio amplifier board. And any wrong signals get in there are going to cause you all kinds of pain, as we'll find out when we talk about that in a little bit.
But yeah, but we used to joke that one of the AM breakthrough, one of our nemesises was Radio Marti, which is a U.S. government station aimed at Cuba. And you guys have heard this joke before, but maybe some of the guys who are on the Discord board haven't. We spent so much time listening to Spanish language Radio Marti that Dean, who doesn't speak Spanish, suddenly developed an urge to overthrow a certain Caribbean island government.
Yeah, yeah. I want that radio station to stop. So, a challenge that a lot of the guys had was in just winding the toroids. Now, a trifilar wound transformer, when you first look at it, it looks very complicated because you wind three wires together and then you wind it around the toroid a bunch of times. And then when you get done, you get six leads. And it's like, what do I do with these six leads and where do they go? And some of them have to be wired together and some don't. But if you stop and think about what's actually happening, it's actually a little simpler than you think. It's really a bifilar wound transformer with another winding. And the one winding is not connected to anything. So the one winding is just straight through, top to bottom, not connected. The other two windings, you take the top of one and the bottom of one and you solder it together. You're done. It's not as hard as you think it is. I tried to demonstrate it on the video, and even so, people were still really struggling.
You know, I this
Um,
this is one where when we tried to do this with the students at the high school, I was the one who chickened out because I said to myself, like the night or two before, I said, these kids are never going to be able to do this. We've only got them for like an hour and a half. We're likely to spend a full hour and a half telling them how to set this thing up. So we chickened out on that. With the high school students, I went ahead and pre-prepared 15 toroidal coils, toroidal trifiller transformers. No, it was more than that because we needed one per. I think we needed two per. So it was like
it
30
was
of them, 30 of
30
them,
of them. Yeah.
30 of them, and we brought them in. And so the guys, the hams who built this receiver went way beyond the students at the high school in that they wound the hams wound their own toroidal transformers.
And it's easy to say that it's simple because everything's simple once you understand it, right? When you don't understand it when it's new, it's very complicated. The first time I ever built one of these things, I laboriously put masking tape on each lead, and I wrote A top, A bottom, B top, B bottom. I don't do that anymore. I buzz them out. I solder two together. I pull the other ones back. I know
You,
it's
you
called
develop tricks
experience.
tricks of doing it, yeah. But it's the first time you're doing it. It's really scary. Dean, you mentioned the diplexer, and I've been corrected. For a while I was saying diplexer, diplexer. We took one from an important piece of ham radio history, and that is Roy Llewellyn's optimized QRP transceiver. I don't know whether we used it completely correctly because it was supposed to feed into a 50 ohm amplifier, and I think the impedance on our AF amplifier is higher than 50 ohms. But it was another one of these things where we put it in there and it knocked down the AM breakthrough quite a bit. We were getting a lot of AM breakthrough from Radio Marti, and then we put the diplexer in there, and it was fine. So
Yeah,
anyway,
I think I
thanks.
think that's right. And again, it's another case of Roy did not invent diplexer circuits.
Right,
Okay.
right, right. Yeah.
So we are just kind of, what do we say? It's not that I see further, I stand on the shoulders of giants. That's all we're all doing as we do this stuff.
It's a good
All right.
Newton quote. Yeah.
So Basta with the mixer, we done?
Um, yeah, I think we're on to the bandpass filter.
probably the simplest circuit in the radio, and the one that seemed to give people the most vexing challenges
It was
because
amazing. It was amazing how vexing it was.
yeah, I mean it's just the concept of what does a filter do, right? It's band pass. It passes a band of frequencies. It stops frequencies that are outside the band. And understanding that our bandpass filter is about as simple a filter as you can get. It's two LC circuits that are tuned to the same frequency, which is the center of the 40-meter band, coupled with a coupling capacitor. That is the entire circuit.
Yeah.
Now, I think part of the problem is that a lot of our builders are coming from the digital world where there are precise ways of doing things, and we're winding toroids. And so when we say it should be about 2 microhenry, it really means it's about, and we don't know exactly what it is. And they'd measure it with a cheap LCR meter that didn't actually work really well and get a different value. And the capacitance, we specifically said put in a fixed capacitor in parallel with a trimmer because we got to trim this circuit to get it resonant at where we want it. Otherwise, it's going to be too high or too low. And this seemed to be a big challenge
Yeah.
for a lot of the
I
guys.
think I think one of the challenges, the best way to illustrate this was that when we told them that after they wind the toroid, they're only going to have an approximation of what the inductance is supposed to be. I mean, the chart might tell you that it's 2.3 microhenries, but it might be 2, it might be 2.6. And what you have to do is you have to scrunch the coil or unscrunch the coil. This is about as undigital as you could get.
Or worse, you have to take a winding off or add a winding.
And you might have to do that. And all that kind of stuff. It's a good illustration of the divide between the digital world where things are precise and perfect and digital, and it's either a one or a zero, and the analog world where it's none of those things. It's sort of close, get as close as you can get, and then scrunch the coil if you have to.
So a lot of the guys learn to use their nano VNAs on this for the first time, and that's great because a nano VNA is a really good tool for looking at a filter. The important things to remember about using the nano VNA to do this is calibrate it. And everybody wanted me to teach them to use nano VNA, and I said no, just go look at Alan's videos. Go look at W2A. He's got a whole series of them. They're perfect. They tell you everything you need to know. Do what he says, and then come back and measure your filter. And a lot of the guys finally did that, and they found that when you have the VNA hooked up to the filter properly, you can actually turn the trimmer capacitors, and you can actually watch the filter shape take shape and get it centered where you want, get the passband where you want. It's a really great tool for that
This
kind
is
of thing.
one of the happiest moments that we had with the high school students. I remember there was a small group of girl students who had finished the BP filter, and Mike Magnotti came over with a nano VNA and showed them how to calibrate it, how to hook it up, and then they just sit there looking at the screen. They turned that coupling capacitor and zeroed it right in, and they had a very low loss. They had it resonant right where they needed it. It was really a good moment, and it was a great use of the tool.
And what a great way to make the theory come to life, because in your hands, you're changing the capacitance and you're watching the filter shape change. And you are very fortunate. We are very fortunate to be in this era of homebrew radio. Just 5 years ago, that tool did not exist. You couldn't,
No,
and a vector network analyzer was unobtainium for most of us.
and you would tell people, well, just listen to it and tune it around until it sounds best. Well, you didn't know what the filter shape looked like. It could have been like, a two camel hump, and or it could have been just way too peaky and not flat enough at the top. But when you put the nano VNA in there, you can get it exactly the way you want it.
So here's another secret. Don't tell anybody, Bill.
Okay.
If you build the filter exactly the way we described, and you just center the tuning caps, that it'll work. It may not be perfect, but it'll work as a filter. It might
Well,
be a little low, it might be a little high, it might not, but it's a simple direct conversion receiver. It will actually work if you just build it and wire it in.
we had a couple cases where guys were getting so frustrated because they could not get the BP filter to do the very simple thing that it was supposed to do. And they were unsure whether it was the BP filter, the PTO, the mixer, or whatever. And we would tell them, okay, just try it without the BP filter now. Just hook up the antenna to the mixer and see if it works that way. And oh yeah, it worked. Okay, then now you got to go back to the BP filter. You got to make sure the BP filter is passing the right frequencies. And so little by little, but these are the lessons that come from homebrew projects, and it was a lot of fun.
So now we move on to the
Uh,
dreaded three transistor with an audio transformer audio amplifier.
yeah, an amalgam of two circuits that I used and that kind of cost me a lot of trouble in my ham radio youth. One, it comes out of part of the amplifier comes out of the Hearing Aid 5 receiver, which appeared in QST at about 1976, 1977. The other was, it appears in one of the Forrest Mims books. At first, we thought we were just going to go with two transistors, but we decided to go with three because we thought that the students needed a desire to power a small loudspeaker. We did not want to have a receiver where you had to plug in headphones and listen to it that way. We didn't think that was really that good of an idea. It was better to have three and to have it power a small loudspeaker, so we went that way.
And this circuit, you said it kind of is an amalgam. We used some Forrest Mims ideas. We used the Hearing Aid 5. We went back and looked at Wes Hayward's original paper on the direct conversion receiver and looked at how he did it. And he used three transistors in a slightly different configuration. But I'll tell you, a lot of the challenges that, and I don't want to call it whining, but a lot of the issues people seem to have is that audio transformer, which goes from 1K to 8 ohms, is less easy to obtain in some parts of the world than it is here. And even in the US, it's not real common. You can get it on Mauser, but you have to pay, you have to pay the shipping. We found that the ones on Amazon, at least the ones we tried at first, which were easy to obtain, were not actually 1K to 8 ohm transformers, and they didn't really work. And so this has caused many of our builders to want to just abandon the circuit and put an LM386 in or be done with it, or worse, use some complex push-pull amplifier scheme. And all we've told them is that's not what we built and that's not what we're building. And try and build it the way we described, because otherwise, again, it's an internet project. We're helping people all over the world. You build a different circuit than we built, we can't really help you.
Yeah, and the reason that the transformer has sort of become difficult to obtain, and not impossible, but a little bit difficult to obtain, is precisely because of circuits like the LM386. Because if you put an LM386 IC in there, you could just take the output and you don't need a transformer. The transformer was needed in the days before the LM386 and similar op amps because the output circuit was a discrete transistor, and it would usually require about 1,000 ohms. The speaker was usually about 8 ohms, so you ended up with a 1,000 to 8 transformer. But we also decided not to go with the LM386, and this was an important choice that we made because we felt that if we wanted to have people homebrew the entire receiver, they should homebrew the entire receiver. And taking a chip and sticking it into a socket just meant for me, and I know people have differences of opinion on this, but for me, it seems like you're allowing somebody else to build your audio amplifier. Here's the other thing. A lot of the builders would cry and complain that the audio amplifier was oscillating. It was just oscillating, it was out of control. We told them, look, all amplifiers aspire to be oscillators. And if you don't treat them carefully, if you don't build them carefully, they will oscillate. But the idea that we got from a lot of the builders was, well, if only you guys had gone the sensible way and gone with an LM386, then we wouldn't have this oscillation problem, don't you know?
Bzzzt,
Not
wrong.
not true, not true, because I mean, you're looking at guys who have built audio amplifiers with LM386s, and they scream like a banshee if you don't have the capacitor in the right place, or if you don't do something right, if you just look at them a little bit wrong. So I think it's a mistake to assume that if we had just gone with the LM386 or a similar audio amplifier, we would not have had the oscillation problems. No, we would have had the oscillation problems, and we would not have had the experience of actually building an audio amplifier, which we thought was important.
Yeah, we also made a conscious effort in designing the amplifier circuit to go with three common emitter amplifiers with no feedback. These are the common emitter amplifier. You can find dozens of YouTube videos on it. Our architecture for the common emitter amplifier is exactly the same as you'll see in every textbook of a standard common emitter amplifier. We use a voltage divider, resistive voltage divider to set the bias. We have a bypass capacitor on the emitter. Um, you know, it's a stock standard common emitter amplifier. And so if you want to understand how these amplifiers work, look at any tutorial on common emitter amplifiers. We use three of them right, right in a row. They're essentially identical except for the last one, which shocker has a smaller emitter resistor than the others, but they're all identical and easy to understand. No feedback. Now this means though, because there's no feedback, that a bit of the gain of the amplifier is dependent on the HFE of the individual transistors. And if you have transistors that happen to be very high HFE, say over 300, you may end up with more oscillation than if they're at, say, 200. We have not kind of broached this broadly with the maker community because we didn't want to get people down the rabbit hole of measuring all their transistors with a transistor tester. Um, and I also built a bunch with this new one was with a new batch of transistors from Mauser that all have a HFE of 285, which is pretty high because they'll often say it's around 100, and it worked fine. I was able to get it not to oscillate just by putting in a little. We have a Band-Aid, a 220 ohm resistor in parallel with the pot, which drops the gain down, and that seemed to work fine.
Yeah, we discovered the issue of HFE. We were reminded of it. One of the reasons that people will put feedback circuits in there is because they want to make the amplifier what's called beta independent. They want the gain of the amplifier to be set by the peripheral components in the circuit, not by the transistor itself, because as Dean indicates, there's big variation, even among 2N3904s, for example, even in the same batch, you'll find some of them that have an HFE or a gain down around 130, 140, others are up around 300. Now, I think we discovered because one of the really experienced builders in the Vienna Wireless Society, Mike Magnotti, built his, and he came in and he said, "Jesus, it's screaming like a banshee." Well, one of the reasons might be is that Mike might have just, without realizing it, put in some very high gain transistors where we may have been using very low gain transistors. But as Dean said, it's kind of hard to tell what the problem is. Most of the time, what we discovered when these amplifiers became oscillators was that it was the result of poor wiring choices on the part of the builders. That they would have inputs getting too close to outputs, and they would create a situation where they would provide a feedback path to the amplifier that would meet the Barkhausen criteria and whoop, just like as and we would say, if you take a microphone on a PA system and you get it too close to the speaker, you've moved the input too close to the output, and the thing is going to take off sort of like a cat chasing its tail. So it was a good experience. These oscillations actually provided a good experience. How are you going to stop this amplifier from oscillating? One, you got the Band-Aid resistor that Dean mentioned. You might want to put that in there. You might want to put some additional decoupling caps on the 12-volt rail. You want to make sure that the wires that you have going to your pot are
Hey,
not
Bill.
laying alongside.
Bill,
Yeah,
do you have your receiver handy?
I
Hold,
do.
hold it up again. Hold it up again and show the back of it. See that gray wire that's coming from the volume pot? That is a shielded wire.
Right
That makes
there.
a huge difference. Now, when I did it, I just braided some wire together and that works. But a shielded wire from the volume pot can make all the difference because
Because
there's
what
no way.
we're trying to do is we're trying to prevent the output here which is coming from the transformer, which is going to the speaker, right? We don't want any of that making its way, and there's a lot of ways it could make its way back. It could make its way just by direct coupling because the two wires could form a capacitor. It could make its way back through the power circuit, through the 12-volt line up here across the top. You just want to make sure that it doesn't. And as Dean indicates, the shielding, this is shielding and it's shielded to ground. It makes it less likely that the output will get closer to the input and that the cat will chase its tail.
Yeah, so good construction practices make all the difference. And just taking care and realizing that at some at some point, by the way, just like on your, hi-fi or stereo at home, if you turn the volume up too loud, your speakers are going to buzz because you're overdriving the speakers. So you shouldn't, on 40 meters, honestly, you should not need to have the volume pot at 100%. If you do, there's something else going on. You need a better antenna or something else.
Yeah, well, sometimes we get guys who would want to test the audio amplifier, and so they wouldn't have it connected to anything else. They would just be sitting there on the table. They would apply power. They would have the gain pot all the way over. They would turn it on, and it would oscillate, and they would say, "Oh my God, it's broken," and turn it off. And what we would say was, "No, wait a second. Turn the gain all the way down. Hook up the mixer. Hook up an antenna." And see if it'll work. See if the hooking up will stabilize things a little bit. And a lot of
the
times
the
it
other
did.
the other misconception I think was that you can just take an inexpensive signal generator, turn it down to say 25 millivolts or 50 millivolts, and feed that into the audio amplifier. And the fact is, almost any setting on your inexpensive signal generator is going to overdrive that amplifier. Because if you think about it, an S9 signal coming in at the antenna port is 50 microvolts RMS. 50
Micro, not
microvolts.
not milli, micro.
Micro, minus 73 dBm. It is a tiny signal.
And that's an
And
S9 signal. That's a
and it
very
gets
strong signal.
tinier when it works through your receiver. You got some loss in the bandpass filter. You have insertion loss in the mixer. So what's coming out of that mixer is a very weak signal. And that's what the audio amplifier, we have 80 to 100 dB of gain in the audio amplifier itself. And so if you put any kind of a strong signal in the millivolt range in there, you're going to overdrive the amplifier and it's going to buzz and it's not going to sound good. And when you overdrive it, you're also more likely to go into oscillation. So when I demonstrated it on the the video, the only stage I actually used a signal generator for was the first stage, just to say it's buzzing. And I actually said, it's really hot. I got to turn the amplitude down. But by the time I added the second stage, I didn't bother using the signal generator anymore because all I had to do was take a screwdriver and touch the input, and the thing goes bzzz,
This is
bzzz.
an area where, again, I think folks from the software world just found this bizarre that we would say, just take your finger and touch it to the input and see if you can hear it buzzing. And you could almost see this look of like, what the hell are you talking about? Taking my finger and putting it on the input? But that's what it is, because what's happening is your finger, your body is picking up 60 hertz signal from the electricity that's all around you. And you're just, when you touch the input, you're putting a little bit of that signal in there, and that's the buzzing that you hear. So
I
actually,
found if I use a screwdriver, it's a little louder.
yeah,
So
it is. The screwdriver makes better contact. I find it more satisfying to lick my finger and stick it in there. Um, but don't try this with any high voltage equipment. But when you're dealing with 9 volts, you probably can get away with it. But it's a good way to test it. But people resisted this. They said, no, 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 I need a signal generator. I need to put it in there. And then that created all kinds of problems that Dean mentioned.
yeah, so that's the four boards, and Bill, I don't know if you want to take a break and do some shameless commerce before we move on, or how do you want to proceed here?
Well, I wasn't going to do it, but since you mentioned it, all right. We really like the Patreon people who become Patreons, the sponsors, and there's a Patreon link on the SolderSmoke page. Sign up, become a Patreon sponsor, and you'll be supporting efforts like this, uh, and podcasts, future podcasts in the future, and things like that. But efforts like building the this receiver, we Dean and I hope to be somehow involved in things like this in the future, and so Yeah, go ahead. Take a look at the Patreon
And
link.
my wages for being the internet's electronics instructor are very low. So
He has become, listen, I might be the might be the mixerologist. Dean has become the oscilloscope whisperer.
well, one of our Todd Vasily, I think it was Todd that wrote to us. No, it wasn't Todd. Who was it that wrote to us to talk about the sage on the stage and the guide
Oh,
on the side?
that was Todd out in Portland. The other
The other
Todd,
Todd, yeah.
W7TFC.
Yeah, so what he said was a lot of times when you're teaching, the the teacher wants to be the guide on the side that just kind of helps you along. The students want you to be the sage on the stage that just spoon feeds them the answers. And so we're trying to find the balance between being the guide on the side and the sage on the stage. And sometimes it's difficult to find. And sometimes you find yourself saying, just do it the way we told you and go read a book. Because I don't, again, I'm not an electrical engineer. I'm certainly not an electrical engineering professor. So there comes a point where it's like I've run out of what because my knowledge, stops about here,
Well,
and
well,
I've run out of what I can share with you.
but Dean had a good answer when somebody, w without mentioning any names, somebody had completed the receiver. The receiver was working fine, but they wanted to continue to test and poke and probe and everything else. And Dean said to him, "Look, dude, you are trying to pull defeat from the jaws of victory." Stop.
Yeah,
And
I used to tell that to my when I was in the commercial world and I had salesmen working for me. I told them, once you've made the sale, stop selling.
yeah.
The deal is closed.
Anyway, I think we're going to share some tales of woe at this point, Dean.
Yeah, probably the most common tale of woe is just miswiring and inability to read the schematics. And, reading the schematics is a skill, just like anything else. I remember just a few years ago, I would look at a schematic and my eyes would glaze over because it's a bunch of little parts and wires running back and forth, and you don't know the theory and you don't know how to identify the different boards. So one of the reasons we did this is 4 boards, and even though there is a master schematic, I never refer to it. I only refer to each individual board is because each individual board allows you to isolate, oh, that's what an oscillator circuit looks like. And once you recognize the pattern, you'll be able to look at, say, Farhan's big BitX40 schematic and find the oscillator circuit and find the mixer circuit and find the amplifier circuits. So learning to read a schematic is a part of homebrewing.
It is very
Now,
important. It's an
I
important
would
part.
also tell you though, Bill, we didn't want to mention the KIT 3-letter word, but it's different. With a kit, you don't necessarily need a schematic. You don't even need to think about it because you got a board that's labeled, you got a bag of parts, you put the parts in the label board, you follow it, and you're done. With this kind of building, you're working from a schematic and you're working from first principle.
We had an excellent example of this during the course of this project. Dean, and you probably can see them behind him there on the video, those of you who are looking, had to assemble 2 IKEA wooden shelves that he was going to use in the shack. There they are. They're beautiful, right? He was going to have to assemble them. He assembled them. And then he asked me rhetorically, he said, "Does this make me a carpenter?" And I said, "No, it doesn't." I remember I took a lot of heat. I took a lot of heat from guys who said Bill is a kit hater. He's a hater. He's hating on the kits. No, I just think that it's better to do it the way we've done it. Now, what Dean just said is very important about seeing a larger schematic as a collection of subcircuits. Pete and I had one time an experience where a guy was writing to us and he told us that he wanted to build, I think it was a superhet receiver. And we tried to say to him, look, you should really start out small, build an oscillator first. But he was determined that he was going to build a superhet receiver. So then we said, okay, we said to him, now, one of the things you should do is when you look at that schematic, make sure you see it not as a whole mass of parts on a board, but as a collection of subcircuits. Just look at it and look at it that way. And for us, it was natural. He came back a couple days later and he said, I've stared at this schematic incessantly and I cannot see the subcircuits in it. And Pete and I both, we shared an email later on and we said, well, that might be an indication that you're biting off more than you could chew. You might want to back off a little bit. There's another indication right there. So what Dean is saying is very true about.
For many
about
of our projects, because we're using circuits we've built before, because Bill and I now both have a box of boards that might someday be rigs. They're boards we built for other projects that we don't use. Sometimes we'll just put a thing together, and we know enough now with experience that, okay, I got a couple of the oscillator to the mixer, I got a couple of mixer to the audio amplifier. We just do it, and we don't do a full schematic. And people say, well, where's the schematic? And I'm like, there really isn't one. Because I didn't build it that way, and that's important. But let's move on to the tales of woe. So transistors in backwards this is another big one. And you need to check the data sheet on your brand. And it turns out in some cases, a transistor with the same designation may actually have different pinouts if you get it from a different manufacturer. It's unusual, but it happens. So you want to make sure you're checking it.
I had this case happen with something as simple as a 2N2222, a popcorn transistor. There's a different kind that's called a PN2222, and the emitter and the collector are reversed. Believe
And who
me,
would have thought that that little letter P made all the difference?
it made all the difference. But I came to trust more the pinouts that I would see online. So I would just go to Google, type in the type of transistor, click on images, and right away pinouts would pop up. And if I saw most of them saying that it's this way, I would kind of tend to think it's that way. However, if half of them said it was this way and half of them said it was the other way, then I'd say, "Oh, watch out, because this might be a trap waiting to be sprung on me."
All right. So the other big tale of woe, um, they talk about lies, horrid lie, wicked lies, and statistics. Well, in our case, it was lying test equipment, and the test equipment was lying for a variety of reasons, not the ones you might think. Um, J W3V3 had unreliable measurements from an old Fluke auto-ranging multimeter. A Fluke multimeter giving him bad outputs. Who would have thought? So understanding that you've got uh, um, uh, uh, that your tools are working the way they're supposed to is really, really important. Another one was the importance of using a 10x probe with scope termination set to the importance of not using a 10x probe with scope termination set to 50 ohms. And Alan, W2AEW, helped us understand the importance of having the proper termination. And so we had Phil, W1PJE, went through that experience, and that was a big tale of woe for him. Peter, by the way, VK3PTM, one of our most successful builders, struggled because he had a transistor in backwards, and his component tester was showing him the emitter and the collector reversed. Bad component tester bought from some overseas country destined for the trash bin. Many, 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 many more setup issues with scopes, signal generators, tiny SAs, nano VNAs. I think people had more trouble with the test equipment than actually building the circuits in many cases. And so learning to use your equipment, really, really important. And in a few cases, but not many, there were actually some bad parts. And the parts that tended to be bad were the ones that they didn't follow the basic guidance on, like the caps for the oscillator. So those are some of the big tales of woe.
Yeah. And then that leads us, I think, to lessons learned. We had some good lessons learned.
We did. I think there's been we have on the Discord channel, we have a Hall of Fame where people are starting to post, and I've collected a few of them, but I think the one that I take the most pleasure in is the guys that say something as simple as, wow, I've been a ham for 48 years and I didn't know I could do this. I've never done anything like this. Thank you. You've opened up a world to me. I'm going to do more of this home brewing. And that to me says we succeeded in what we wanted to do, which is open up this world of homebrew ham radio to maybe an older generation, maybe a younger generation, but a new generation of home brewers. Wade, VA3NCA, said, taking care when choosing junk drawer components, solidifying concepts introduced in the licensing material benefit of hands-on experience and building them made them more real. And, that's exactly right. There's something about putting solder to the board, putting every component on yourself, measuring every component that helps take all the theory that you've read, because you can memorize the theory for the exam. And I more or less did that. I went through the three sections of the exam in about 2 months, but I wouldn't say I learned anything until I started building.
You know,
Don't trust your transistor. Go ahead, Bill.
this gets to the issue about whether a kit would provide the same experience, and I really don't think it would. Not to beat a dead horse here, but you could, if you got a bag of parts that have already been pre-screened so that all the parts are good, well, and then you just take the parts and put them on a board, and the only thing you're really checking is soldering. You could complete the entire kit and not know anything about electronics. I mean, that was the ethos behind Heathkit. Heathkit was very successful, and they said they wanted to design their kits and do their books so that someone who knew nothing about electronics could successfully build their kits. So I think the same thing, not all kits are like that. Some kits require you to learn more, which is good. But in general, I think it's much better to do what we did, and that is to have people actually homebrew it, actually build it themselves. And I think that
I
gives a
guess
much more
let, let's
satisfying
let's let,
experience.
let's address this issue of better. By better, we don't mean that if you build a kit, you are wrong or that you're
No,
doing anything illegal or immoral or unsocial. We just mean it's a different experience. And that's all we mean.
that's
And
it.
and both Bill and I have built kits and we'll continue to build kits for things that we want to build kits for. But there's a different experience when you're doing it kind of from the ground up that we do. Okay, some other lessons learned. Don't trust your transistor tester. Okay, make sure your instruments aren't lying to you. Here's something that was an eye opener to some people, that you can reverse the emitter collector and the transistor may still pass a signal, may not, but it may. You can have the source and the drain of a FET reversed. And for the J310, it actually doesn't matter. You can hook it up either way and it'll work, but not true on all FETs, but that is true for the J310. So um, learning to use your test equipment, get it right, have the right probes. Big learning for many of our guys was the importance of those mica caps in stability. You know, and I think another one of the gratifying lessons learned is learning to trust your troubleshooting after you've done something and fixed a circuit. So one guy had a faulty transistor, and following our guidance, he went through stage by stage by stage. He found the faulty transistor, he put in the new one, and the audio amplifier came to life. And that, Bill, you can attest to this. When you fix a problem in a circuit, there's a satisfying feeling. It's like, all right, I did it. That's a satisfying fix. I identified the problem, I fixed the problem in a way that and it fixed it, and it actually worked.
I always think that a good troubleshoot where the problem is complicated and it's not just a matter of squirting some deoxit in there or something like that. It's almost as satisfying as home brewing a piece of gear. It's almost as satisfying.
Yeah. So a couple of more just general comments before we wrap up. Part sourcing. This was a little bit of a surprise to me, how much time people spent on agonizing over sourcing the parts. Um, One, you need to understand the circuit, and I tried in the videos to point out that there are some components that are pretty important, like the mica caps and being the right value, because they're part of a circuit that determines the frequency of your receiver, and you can't vary from that too much. But in other cases, the difference between 100 ohm, 150 ohm, sometimes even a 50 ohm and 100 ohm just doesn't make that much difference in this. So I tried to point out where the values simply were not critical. And that should help you say, well, when I got to do shopping, what do I have to buy and what do I not need to buy? The other thing is these these sites are great. Mauser, DigiKey, and others are great, but they have hundreds of thousands of components. So spending a little bit of time learning to navigate their website is useful, because you can say, I want a zero point 0.1 microfarad cap, and you're going to get 1,000 different components and surface mount and different leads. So it just takes a little time to learn. But if shopping is your biggest challenge, again, like Bill was saying, maybe this is not what the thing you want to be in. You can figure this out.
I think that this just points out the usefulness of having a relatively large junk box. In other words, don't buy 1.1 microfarad capacitor, buy a bunch of them because you know you're going to need them in the future. It also points out the importance of Hamfest and going to Hamfest and saying, I'm going to buy some of this stuff. You know, you need to organize it a little bit, but it's good to have on hand a certain amount of parts or know where you could get them or think about salvaging stuff like that transformer. You could pull that transformer out of old radios. You could come up with it that way. You don't have to get it from Mauser or DigiKey. You could try to get it someplace else. You could get it from another ham. You could get it from an Elmer, somebody who's helping you, things like that. But we were kind of surprised at how much time was spent on basically
Let,
part sourcing.
let's talk about expense for a little bit because this is also an issue. Bill is cheap. I'm cheap. Hams are cheap. We're all cheap. We don't want to spend more than we have to on anything. But it gets a little silly at a certain point. Okay. Uh, all of us have, many of us have commercial gear in our shack. Many of you out there have $1,000 or multi-$1,000 rigs in your shack. I'm guessing that in 5 years of doing homebrew radio, building five or six transceivers and receivers, and buying more parts than you're ever going to buy, because I decided at one point I wanted every possible value of resistor, so I didn't have to go mix and match. I'll probably have spent less than the cost of one ICOM 7300, and I have had many, 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 many hundreds of hours of pleasure and fun using it. So yeah, I can say to you that the total cost of parts of our direct conversion receiver is $10, which it probably is. But if you have zero, you got to start building up your junk box and don't think of it as geez, I just spent $50 on a $10 receiver. No, you spent $50 and you started building up because all the components we use in here, every single component we use in here are common components that are used in every circuit you're ever going to build. Zero point 0.1 microfarad caps are used all over the place when you build these things. 2N3904 transistors. Probably the only component you may not ever use again is the auto transformer. And I'm sorry, but it's $4 or $5, and you may have to pay shipping. But it's part of the learning experience. It is part of what we're trying to accomplish here. So, building up your junk box. Don't be afraid to spend a little bit of money. Hey, if it's less than the cost of a couple of Starbucks, you're probably okay.
Yeah. Yeah, I mean, we all, Dean talked about how we're cheap because I got started in this when I was 13. And I remember looking at something and saying, holy cow, $6. $6. I'm not going to spend $6 on that thing. These attitudes stay with you. But anyway,
They do, and again, I have it. I have it too, so I get it. But I'm just keep perspective on some of these. Now, for some of our folks that live on remote parts of the world, it can be a challenge. And look, we're not saying don't build the rig the way you want to build it. All we're saying is if you want to build the SolderSmoke challenge, build it the way we said.
that's right.
And if you want to come to our Discord channel and ask us to help you to debug your circuit, it better be the circuit that's on the schematic that we posted. Because
Yeah.
otherwise, I'm done being the electronics coach for the internet, right?
One thing we did come up with sort of an interim solution. Some guys who might desperately not be able to get that transformer might have to go with another circuit. We'll see that as sort of an interim solution. If you get the thing to work, there'll be a little asterisk or something uh,
On the wall of on the
on the Hall of
wall
Fame
of fame, yeah.
saying it's pending. And when you do eventually get the transformer, build the circuit as we said, and then boom, you'll be in the hallowed halls of the Solder Smoke Hall of Fame.
We had one or two builders who clearly don't have HF stations at home, so they don't have a dipole in back or they don't have an antenna. So antennas are a bit of a challenge. Bill has demonstrated that if you put 33 33 feet of wire and hook it up to the bandpass filter input, drop it out your window, take another 33 feet of wire, clip it to the ground and drop it on the floor, you have an antenna that will receive well enough. And particularly when 40 is open in the early evening and the early morning, you're going to receive lots of strong song signals on there.
Yeah,
It's
this
not as difficult as you think it is, but you do have to have an antenna in order
yeah,
to receive.
on this, this is an important difference, a generational difference. I think a lot of newer hams have the idea that the antenna is somehow optional. It's just not that important. This is the way it is with a lot of consumer electronics. I mean, the radio stereo will work just if you don't have an antenna or not. Not true with ham radio stuff. You really do need the antenna. We've tried to find ways to kind of recommend to do things a little bit easier. If you have some Cat5 cable sitting around, you could use that as in lieu of buying some expensive coax or something like that, especially for a receiver. But you know, the antenna thing, there's so much information on the internet. I mean, you just go ham radio antenna and you will have stuff that you could look at till the end of time on the internet. It's a good way to sort of enlighten yourself. But you do, I mean, I think the general guidance is more wire up higher is better, and watch out for power lines because that's one of the main ways that ham radio operators get killed. They throw a wire over a high voltage line outside, and boom, the show's over. Don't do that.
Bad idea.
Bad
So
idea.
so so looking ahead, you built the four boards, you're excited. What else are you going to do? Well, we got a lot of guys out there that say, I want to do a transmitter next, and I want to do, they'll say, well, I'm a CW guy and I want to do a CW transmitter. And we say, well, if you want to make a transceiver with CW, you have to worry about things like shifting the frequency. Otherwise, you're going to be chasing the other guy up the dial because you can't listen and transmit on the same frequency. Because if you listen on your transmit frequency, you're going to hear nothing because you have zero beat. So we say probably harder than you think. Then they'll say, well, I want to do a super hit multi-band transceiver next. I'm like, no, you probably don't for all the reasons we talked about earlier. But a double sideband transmitter in conjunction with the PTO you've already built, again, it's just a couple more boards. You need a microphone amplifier, another mixer, unless you want to go through all the trouble of switching the mixer in and out, which I wouldn't bother with. Just build another mixer. You need some little bit of RF amplification, and there's lots of circuits out there, and a low-pass filter. So again, four more boards, and you have a transmitter, and a little bit of switching logic to switch from transmit and receive. And we've already had some builders build a DSP transmitter. I don't know that we're going to take everybody through that in the detail that we did here, because again, for the past month, I've been spending 5 or 6 hours a day on Discord. so that's not something I can sustain, but I've already built one. I may actually throw another one together and say, here's what I did, just to give you an idea.
Dean's right. I think this gets us to, the final kind of like, what lessons did we take as kind of challengers or instructors in this whole thing? And one thing I would say, and it's kind of a hard thing to say, but it's important to say it. One of the difference between home brewing and commercial gear and kit building is that when you're home brewing, the responsibility is on you. It's your machine that you're making, and it's your responsibility to make that machine work or not. And it's important to care about it enough and to stick with it enough to get it to work. I mean, you can't send it back. There's no factory that you could send it back to. There's no kit marketer you could send it back to and say, please help me because I can't make this thing work. No, this is a homebrew piece of gear, and it's up to you, seeking help from Elmers and people who can advise you. But really, it's on you to make the thing work, especially if it's a design that you know that others have made work, and we've got 25 or 30 of these things around the world working. So the design is okay. Make it work. You could do it. Don't let this thing gather shelf space and gather dust in the shelf of shame. So you could do that.
And even though he's not with us today, I've got Pete's voice in the back of my head all the time. The radio does not build itself.
That's right. That's right.
You have to build it.
You have to build it. Along these same lines, be careful about who you get advice from, because a lot of people it's a good thing. They want to be helpful. But ask yourself, is the person who's giving you advice, are they an experienced home brewer, or are they somebody who is as experienced as you are, in which case the advice might not be all that great. You really have to, it's a judgment call. You have to figure it out. And also be careful about giving advice. If you're giving advice, ask yourself, am I really an experienced home brewer? Don't be afraid to say, I don't know. You should be willing to say that. If somebody asks you a question, Dean and I have said this many times, I think during this whole process, somebody has asked us a question about something and the answer is, geez, I don't know. We're going to find out about that. I don't know. Don't be afraid. So be careful about who
I don't
you.
know, but I'll find out is a perfectly good answer. And
Yeah,
you don't need to comment if you don't know. Just sit back and watch and listen. We've
yeah,
tried to be generous and careful and kind to everybody who's posting and helping out, but occasionally the suggestions for help will send people down the wrong path and they won't actually get it working, or they will just make a bunch of work for somebody that is simply not necessary. So we try and step in and say, yeah, don't do
yeah. I
that.
I don't think that's the problem. That it might be something else, but it's probably not
I
that.
wouldn't do that. And I have directly told some of our Elmers out there that while I appreciate their help, they need to remember that this actually is a beginner project, and we meant it to be simple. We meant it to be easy. We don't want complex solutions to simple problems. If they can step in and say, all right, here's what you need to know about that circuit, that's fine. And do the kind of mentoring that we like, but saying, rip that out and put this other circuit in, not helpful for what we're doing here. So be careful who you take advice from. Um, Again, you may not get it, but it is unusual, it is, I think, unheard of to have the experience that the builders have had for the past 4 weeks, which is you had essentially 24-hour access to me and Bill during that time to answer your questions about doing the build. That's, again, it's not sustainable, but I wanted to do that one time just to kind of demonstrate. And we've recorded it. So all the comments are out there, all our responses are out there. If you started this today, I would say it is unlikely you're going to find a problem that somebody hasn't already had that we haven't already answered. So there's a great archive out there.
Yeah, and the one thing I'd like to point out is that Dean and I both learned a lot during this process. We learned a lot from the builders. We learned how to improve the circuit. Dean found a capacitor that we should have put across the emitter in the J310 circuit that boosted the output quite a bit. We checked it out. We built it in LT Spice. We built it in the real world, and then yeah, that's it. It's better to have that capacitor there. So this receiver, the circuit is better because of the many people who've built it up to this point, and we're grateful for that, and not afraid to say that yeah, we didn't have it perfect when we did it. It's probably not perfect now. There probably is some room for improvement out there, but thanks for that. But
So
Dean,
Bill,
I,
some of our builders are having the nightmare.
I know I wanted to end with the nightmare. This is the homebrew nightmare. And Dean and I have both had it, and many of you have had it or will have it. And that is that you've built the machine. It's all four boards are sitting there looking at you, and it won't work. You can't get it to work. You're not listening to 40 meters. You know there's people out there talking, and you're not hearing them. Nothing. And so you start thinking, well, I'm going to take the parts off this board and I'm going to rebuild. I'm going to take, the next thing you know, you've got four empty boards and a big pile of parts next to you. The thing still doesn't
And there
work.
went 4 weeks of work.
Because I think I've come pretty close to doing that on occasion. And it's certainly been the nightmare that I wake up in the middle of the night and I think about the board and I think, oh my God, it's the board is completely empty and there's a big pile of soldered parts next to it.
But here's what you can do. Take that board that's not working. Again, these are simple circuits. Set it aside, carefully build a second version and see if you have the same results. Because a lot of times the problem was you got a wiring problem you can't see, you got a component that's in the wrong place, and you're just not seeing it. And then when you get one that's working and one that's not, it's easy to compare. You can say, yep, 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 yep. This gets into mods, right? If you want a mod, if you have a working receiver and you change out a module, you know the difference immediately.
Another little bit of advice is that if you really get stuck on a problem and you realize that you're just beating your head against the wall and it's not working, take a break.
Go
Go
for a
walk,
walk,
go walk the dog.
have a
Come,
beer.
come back tomorrow. Let it sit for over the weekend. Pick it up next week. Because when you look at it with a fresh mind, you'll see a lot of physicists, a lot of scientists will talk about this, that somehow they took a break, they came back to the problem, and there the solution was apparent. We don't really know why, but it will happen. So it might work for
Yeah,
you.
and sometimes you wake up in the morning and you say, "Oh, I know what it is."
That's
Right?
it.
It just
You're,
happens
you're
that
sitting
way.
there, you're brushing your teeth, and you think, "Oh my God." Gene Shepard did this in one of his stories. He talks about it. He says, "I know it. I know it. It's R16.
Yeah,
R16 is too high." Something like that. Hey, it's been fun.
it has been.
It's been great. So keep up the good work. Look at the mods page. We've got a couple of mods pages out there. Don't be afraid to mod after you've built it. If you're still building it, wait, build it first once. But then after you finish building it, after you've made it onto the Hall of Fame, go ahead and mod to your heart's content.
And I'm not going to disappear from Discord, but I'm not going to be on there every day, and I'm not going to be real time answering everybody's questions. We talked about this as a 4 week project. Our 4 weeks is done. The information is out there. You can build it, and it'll work. Again, we got 22 of them built and working and sounding great, and another 30 or so in train. And the community itself has come together and provided a good support group as well.
All right, great. Hey, and thanks very much for everybody who's been involved. Thank you, Dean, for your hard work on this thing. All those videos are just fantastic, and it's been great fun. Enjoy those receivers. One other thing, be an Elmer. You built a receiver, and somebody comes to you and says, "What should I do next in ham radio?" Tell them, "Hey, built this receiver. It's out there." It'd be great if we saw kind of a daisy chain process where this receiver is leading to other receivers being built, because you're turning people on to home brewing, and I think it's a good thing for
Club
them as radio
projects.
amateurs. Yeah, they have fun projects. All right, thanks a lot, guys. Thanks,
All right,
Gene.
7-3
7-3 from the Dominican Republic.
and 7-3 from Great Falls.
All right, thanks a lot.